Bismillahirrahmanirrahim. In this session, we will discuss the arc length and sector area in exercise 35.9 in the subject of O-level mathematics, also for IGCSE students. And here we have various sectors of or segments of circles are given, and we have to evaluate these things. Arc length, so we have to find the arc length in this problem. So we have to find this length. This is arc length. And in the next problem, calculate the area of the sector in equation 1. So we have to find the area also in part B or 2, question number 2. Similarly, for calculate the perimeter of each of these sectors, given your answer to 3 significant figures. So we have to calculate the perimeter. So the arc length and this length also. So this is called the perimeter. And similarly, the other questions. So let's start 35.9. So we have to find the arc length and sector area. The arc length is given as this angle theta to this whole circle, and the arc length is this length, and the circumference is the complete circle. So we have this circumference is here. Arc length divided by circumference is equal to theta divided by 360. So arc length is equal to theta divided by 360 into circumference. Circumference is given as 2 pi r. 2 pi is basically the 360 degree angle, and r is the radius. So, and theta is given here. If this is 360 degree, the theta is given in degree. Similarly, the sector area is given as theta divided by 360 into area of this circle. Area of this circle, and this is the sector area. This area is the sector area, and this is the whole area of this circle. So the sector area is equal to theta divided by 360 into area of the circle, which is equals to theta divided by 360 into area of the circle. Sector area is equal to area of the circle here. Calculate the length of each of these sectors, given your answer to 3 significant figures. Here we have this is 40 degree and this length is 5.1. The radius of this circle is 5.1 centimeter. So the arc length is equal to 40 degree. In place of theta, we will place this 40 degree divided by the whole circle, 360 into 2 pi into 5.1. This is the radius. So this is the circumference. So this gives 40 degree divided by 1/9 is 2 pi into 5.1. So this is on multiplying all this, we have this 3.56. Since this is length is centimeter, so this arc length is 3.56 centimeter. So for this we have this angle is 210 degree and this is 3.7. The length arc this radius is 3.7 centimeter. So this is obtained as this. Similarly for this and this one 72 degree, and arc length is 72 degree into 2 pi 4.7 is the radius and 360. So this is 5.91. Calculate the area of the sector of this. So let's solve this one for the area. So this is in place of this is 5.1 and this is 40 degree. So the first one is 40 degree and 360 degree into pi 5.1 degree square. So this is the radius square. So this is area. So 9.08 centimeter square is the sector area for this one. Similarly for this second problem, this one 3.7 is the area and the 210 degree. So in this 200 degree, here we will write the area. So pi and 3.7 square. Pi into 3.7 square, and the answer is this. Uh, 25.1. This is 25.1 centimeter square, and similarly the others one. So this is all easy. We have a theta and 30 degree, and then this is the radius. This is all radius square, pi radius square. In the question number 3, calculate the area of each of this sector in question number 1, given your answer to 3 significant figures. So this was the question number 2, and now calculate the perimeter of each of these sectors. Given your answer to 3 significant figures. So this is 90 degree. So arc length is equal to 90 degree divided by 360 degree into 2 pi into this radius is 7.2. So this sector length is obtained, arc length is obtained, and this length is 7.2, and this is also 7.2. So 7.2 plus this arc length 11.3, this. So this gives the perimeter of this sector. This is the perimeter of this sector is this length, and this arc length. So this is this. Similarly for this length, and this arc length. So we have calculated the arc length, and then this radius, twice radius, and this arc length. Similarly, twice radius and this arc length. So twice radius and this arc length. So in question number 4, calculate the sector angle in each of these sector, given your answer to the nearest degree. So we have this 5.6 centimeter, and this arc length is 4.2. So from this 4.2 we have obtained this angle. So we have to sector angle. So we have to find the angle. Arc length is given as 4.2. So in place of arc length we will write 4.2. In place of the theta degree theta has to find, this is 360 degree, and the arc length is 2 pi r, and in place of r we will write this 5.6. So in place of r 5.6, and we solve this for theta, and theta is obtained 43 degree. Similarly for others problem, this arc length is 12.3. So 12.3 here, theta is here, theta 360 2 pi, and this is 3.8 is the radius is here, and theta is obtained as 185, and this is more than 180 degrees, so it is 185. Similarly for this one, area is given. Here the area is given, so sector area is equal to theta divided by 360 into pi r square. Since the area is given, so we will use the sector area. Sector area is 10.3 centimeter square, and this radius is 4.5 centimeters, so 4.5 here square, and we have obtained this theta. Similarly for this one, this lengths radius are given, and this arc length is 5, so theta is obtained as 57 degree. Similarly for this one and for this one. Calculate question number 5. Calculate the radius of each of these sectors. So we have to calculate the radius. We have given this sector arc length. Arc length is given and the angle is given. So arc length is given as 6 centimeters, and theta is given as 70 degree. So 70 degree, and this is 2 pi, and we have to find this r. We can solve this, simplify it, and we can get the radius up to 3 significant figures. Similarly for this line, this arc length is given, this angle is given, so angle in place of angle, arc length in place of arc length, and we have to find this r, and we have to find this. All these things are known, and we have to find this r. So this is obtained as this. Similarly for this one, calculate the radius of each of these sectors. We have given the sector area and sector angle. So we have given this sector area and angle. So sector area is 19.7 and the angle is 52 degree, and we have to find the radius. So radius can be obtained. This is all given, this given, this is given, this is given. So r square can be obtained, and then take the square root and r can be find out. Similarly for this one, sector area is given, angle is given, pi, and we can have to find the r square, and then r can be calculated. Similarly for this one, so this is all easy. A shape consists of 2 separate sectors of a circle, each with an angle 35 degree and a radius 32 millimeters. They are to be painted blue with their black border. Calculate the total area of the blue and the total length of the black border. So the shape of this is the shape, 2 separate sectors of a circle, and here we have given this is 35 degree and this is also 35 degree. This length is 32 millimeter. This is also 32 millimeters, and they have to be painted blue with a thin black border. So the total area of the blue and the total length of the black border. Give your answer to an appropriate degree of correction, accuracy. So arc length is theta divided by 360 degree into 2 pi r. So this is 19.5. So arc length is obtained as this arc length is 19.5. So this arc length is also 19.5. So we have this two arc length. This is arc length and this is arc length. So twice the arc length, and the radius, this radius, this is also radius, and radius. So 4 radius and 2 arc length. So the perimeter for black border, we have this much millimeter. So this the total perimeter of this two sectors gives this perimeters, which is 167. So we have to paint black border with this much length. For sector area, theta divided by 360 degree into pi r square, and this is r is given as 32 mm square. So this sector area is basically 312.8 millimeter square. So this area of one side is 312. So we have the same area here, so we have twice that area. So we multiply this to sector area, and the total sector area is this for blue painting. So we have to require this 625.6 millimeter square area for blue painting. So we have to paint this whole with blue paint, and this border is a black border. This lining is a black lining. So this is a very important question, and in the next session we will discuss the volume of a prism.